Okay, so this is the answer key for the practice for chapters 3 and 5, okay, which was drawing linear models and function notation. So the first question was the NFL salary cap in millions of dollars. So I have the scatter plot here, and it's not too crazy of a scatter plot. You notice that I did a broken line on this. It wasn't really necessary to do that, but I wanted to go up by tens. But I made a broken line so I could skip a few spots, or skip a few tick marks, and started at 30. Then basically went up by tens for each one. Okay, so each tick mark is worth $10 million. Okay, and then they asked you to draw a linear model. Now I did two different linear models on the answer key. Okay, I didn't tell you what 2 points to use, so you could use whatever 2 points you wanted. Well, the most convenient and easiest ones to use would be to draw your linear model through the S of t intercept. Okay, so that was the very first point on the graph. So I used that point, and then 12 years since 1994, so in the year 2006. Okay, so I used the first year and the year 2006. Okay, and that's a pretty good linear model. Okay, and on the answer key, you're going to see all the work based on that linear model is here if I use the point 0, 34.6, and 12, 102. Okay, so I found the slope between those points, found the linear model, and in that case, what's easiest about this is because you have 0, 34.6, you can plug that right in for the b value, and there's not much work for that. Okay, so that's the most convenient one we used. Okay, and then I go on and explain the slope, okay, what the slope means, and then what the vertical intercept means. Okay, so I'll give you a minute to look at that, and throughout this video, I suggest you're ready to pause it, because I'm not just going to leave it up there for 20 minutes, in real time, waiting for you to look at. You can pause the video at whatever screen you need to see the answers. Okay, so again, this left-hand piece over here is using the point 0, 34.6, and 12, 102. On the right-hand side, that's if you use two different points. So say, for example, you use 6, 62.2, and 12, 102. That linear model would have looked like this. Okay, so I just circled the 2 points that I drew that model through here and here. Okay, so that's what that linear model would look like. And you can see that when you find the vertical intercept, it's going to be less than what the actual value was, 34.6 million in 1994. Okay, so the linear model for this one, if you use two different points rather than the actual value is 0, 34.6, you end up with a lower vertical intercept. Okay, so again, there's the work for each of those. And that one, notice that once you get the slope, and it's a different slope because they're two different points, you have to find the b value by plugging in one of the points. Okay, I just used 12 and 102 to plug in because there was no decimal. Okay, and you end up getting 22.4 for the vertical intercept there, which again is about 12 million lower than the other linear model. Okay, so I'm going to go on to the next page, or the next questions. Okay, and these are all answered based on the first line. Okay, so I'm answering each of these based on this equation right here. Okay, I didn't go through and answer all of them for both equations. Okay, so I just used this one here. Okay, so there's the answers for the rest of that question. Part H, that one's a little bit trickier because they say a player that makes $18 million, what percent of the salary cap would that player take up? Well, it's basically 18 million out of the total, and you find the total by plugging in 21 for the t-value, because that's the year 2015. Okay, and you end up with about 11.79%. Okay. So a player that makes $18 million would take up almost 12% of the team's salary cap that year. Okay, so again, pause that if you need to. I'm going to go on to number 2. Okay, number 2 was a scattergram given the recent Ebola outbreak in Liberia. Okay, that was last year. Remember, they're all freaked out about Ebola. I haven't heard about it in the last several months, which is interesting. Okay, so we have that scatter plot. On the vertical scale, I went up by 300 each. I didn't have to do a broken line on that, but a scale of 300 works pretty nicely. And I just went up by a scale of 1. Okay, so 1 week. 1 tick mark represents 1 week since June 22nd, 2014. And you can see on this one that has that exponential shape to it, meaning there's a curve to it. So as time goes on, it gets steeper and steeper. Okay, which is not linear. Okay, so it's just like what I did in class. Okay, and then, again, if you need to pause it, go ahead. But okay, notice in part D, when you put 0 into the equation, you end up with 73. When you put 3 in, you get 180, and so on. And when you compare those to the actual values in the table, they are fairly close. Okay, as far as the linear model goes that I gave you, the negative 602 for the y-intercept, that'd be down here on the graph. That would make no sense, because you can have negative number of cases. Okay, and all these values here in the table are coming from plugging your t-values into the calculator. Okay, make sure you put the exponent. Okay, so make sure you use the exponent of 0, exponent of 3, 5, and 11. It's not times 0 or times 3. Okay, those are exponents. Okay, if you need help on that, you need to ask me in class or during office hours. Okay, so I'm going to move on to the next questions. Okay, I'm not going to talk much over those. Okay, so I'll just give it a minute to stay there, and then we'll go to the next questions. Okay, remember in number 4, to find intercepts, you in order to find the x-intercept, you let the other variable y be 0. So that's a matter of just putting 0 in for y from your original equation up here. Same thing over here, put 0 in for the y. You end up with 3x equals negative 4. Divide by 3, and that gives you the negative 4/3. Okay, so I'll go to the next one, number 5. Okay, the sketch of the graph starts up at 58. And then the slope is negative, which means the line is decreasing. So eventually it'll hit the t-axis. And then the only other thing to really mention is down here in part F, you find the number of visitors, which was 49.87 thousand. And if you're and if they're bringing in $15 each, you multiply that by 15. To get the revenue of $748.50. $748,050. Okay, so I'm going to go on to the next ones, number 6. Okay, again, pause the video if you need to. This page is going to look crazy. Okay, so I'll cover some of it up so it doesn't get too overwhelming. Okay, number 6, that was the number of inmates. You find the slope, make sure you define your variables. I said let t be the number of years since 2001, and y is the number of inmates. So basically you find 2 points from the information that you're given. You find the slope, and then plug in one of the points to find your b value. Well, this one, the way we defined our variable, 3,147, is your y-intercept. So that was easy to find the b value of 3,147. Okay, I'll go to number 7. Okay, in number 7, okay, the first one, in order to be a linear function, remember the slope has to be the same between each pair of points. So you find the change in x, it was positive 1 each time. The change in y, from 2 to 6 was adding 4. From 6 to 18 is adding 12, and so on. So that rate of change, 4 over 1, 12 over 1, 36 over 1, and so on, is not the same rate of change. So that's not linear. Okay, that's actually an exponential graph, believe it or not. You actually multiply by 3 each time. Okay, so that's an exponential. Okay, and then the other one, you find the change in x and the change in y. And that one, it ends up, the slope is negative 6 divided by 2, negative 12 divided by 4, negative 6 divided by 2, negative 12 divided by 4. Well, negative 6 over 2, because remember, looking at the change in y over change in x, is the same as negative 12 over 4. They both reduce to negative 3. Okay, so that one is a linear function because the slope is always negative 3. Okay, number 8. Okay, this one, I tell you that the tables represent linear functions and you want to fill in the missing table values. Well, this is like one from the first exam, but there's a chance you might see it again. So what we have here, you have to look at the change in the x values in the first table was always adding 1. Well, we notice that the 2 values I gave you, the 100 and the 86, that is going down 14, but x went up by 2. Okay, so from 0 to 2, the x went up by 2, the y went down by 14. So the slope there, negative 14 divided by positive 2, okay, maybe I should have wrote that first. Negative 14 over positive 2 is the same thing as negative 7 over 1. So basically saying, every time y goes down by 14, x had to go up by 2. Or, equivalently, every time y goes down by 7, x goes up by 1. So here, x goes up by 1, y had to go down by 7. Okay, so you basically keep subtracting 7 because x keeps on going up by 1. Okay, similar in the other table here. Okay, we find the slope between the points I gave you, which was 37 minus 2, and then 4 subtract negative 3. Okay, so that's what this is right here, and you end up with 5. Okay, so the slope there is 5, or 5 over 1. That's the same thing as 10 divided by 2, or 15 divided by 3. Okay, or I could have said 20 divided by 4, and so on. But the point is, what this means, every time y goes up by 5, x had to go up by 1. Every time y goes up by 10, x had to go up by 2. Every time y goes up by 15, x had to go up by 3. Okay, so in the first pair of points, the x value went up by 1. From negative 4 to negative 3 is adding 1. So that means the y value had to go up by 5. Well, if we ended at 2, basically take away 5 in the opposite direction, you get negative 3. Okay, and then from negative 3 to 0, you had to add 3 to the x. Well, when x goes up by 3, y goes up by 15. So you add 15 to that y value, and that gives you 17. And then x went up by 1. That meant y had to go up by 5. And then the last one, x went up by 3, which means y went up by 15. Okay, and then the rest of the page here, let me look at, this is, I don't want to get overwhelmed here, 9 through 13. Okay, I ask you what a function is. Okay, so I'll leave that up there. It's really just looking at tables, and number 13 is plugging values into the function rule. Okay, so in number 9, to be a function, each x has only one y. A linear function is a function with a constant slope. Okay, number 10, vertical lines are not functions. Okay, they're the only lines that will not be functions. So for example, like x equals 3, or x equals -2, or x equals 7, those are not functions. Okay, number 11, in order to make a table that's not a function, okay, what has to happen is you have to have an x value that has more than one y. So there's an infinite number of answers for these, but basically I had an x value of 1 going to 2 different y values. That's not a function. Number 12, if all the y values are the same, so I just call them c. That could be 5, it could be 2, it could be 3. So if all the y values are the same number, then that's a horizontal line at y equals whatever that number was. Okay, so y equals c. Okay, number 13 was substituting into a function rule. It was kind of a tricky function rule, but it's all just plug and chug in the calculator, or most of them. You'll notice that f of 0 is undefined because you end up doing 12 divided by 0, which is undefined. And then when you do f of 2n, okay, you might want to make note of the answer there. When you do the 2n, the quantity 2n squared, that means 2n times 2n, which is 4n squared. Multiply that by 3 to get 12n squared, and then we have minus 2n, and then 6 over n, plus 6 over n. Okay, the 6 over n came from reducing the 12 over 2, would be 6 over 1, and the n is still in the bottom, the denominator. Okay, and then 14 and 15, okay, over here on the side. Again, I'm trying not to overwhelm you too much with all the math on there. Okay, but again, it was just using function rules. Okay, so there's the answers there in 14 and 15. Okay, so I'll let you look at those. And then I'll go on to the very last page. Okay, the very last page, 15 was answered on the last page I had up there. Number 16, this is if you're given a table. Can you find function values? Well, remember f of -2. Okay, so f of -2, remember that means that x is -2. Remember that our table is like x and y. Okay, so f of x is a fancy way of saying y, remember. So when you put -2 into your function, that's your x value. So x is -2 right here, and you get 0 for the y value. F of 0 means that x is 0. Well, when x is 0, y is -6. And then f of 4 means that x is 4, the y value is 2. And then part D, find x if f of x equals 0. So that's basically saying that y equals 0. So y equals 0, we find 0 in the y column, and x equals -2. Also notice that we have 0 here when x is +2. So we get two different answers for that one. X equals -2 and x equals +2. Okay, and then finally number 17, that's just reading function values off a graph. Okay, there isn't too much for me to say to that. Okay, so I'll let you look at those. Okay, when you see something like, say, g of 4, that means the x value is 4. So the y value is right here. So I estimated that to be about 5.2. Okay, so just above 5. And then when you look at something like g of x equals 3, that means the y value is 3. Well, the y value is 3, not here, because that's where x is 3. The y value is 3 right here. So we hit the graph right here when x is negative 6, right here when x is negative 4, and right here when x is positive 1. Okay, so that's why those are, you have 3 answers for that one. The last one, g of 1 plus g of 5, basically says find g of 1. Well, when you plug 1 in, you get 3 for an answer. Plug in 5, and you get 6. So that'll be 3 plus 6, which is 9. Okay, so that is the answer key. I tried not to go too fast through it, but you may need to go back and pause or fast forward, rewind, whatever you need to do to get the answers. Okay, if you have questions on it, you can email me or see me in class or office hours, and I'll help you out.